All right, hello honors pre-calculus. I hope everybody's staying warm today. So I figured we'd just launch right into our regularly scheduled notes for the next unit so that we don't get behind. Today is going to be called polar coordinates. So this is a new concept that we have not learned anything about. But we do have the skills to be able to do it. So let's look at number one. It says find the rectangular coordinates of a point that is 12 units from the origin and on the terminal ray of an angle of 5 pi over 6. So as always, we're going to draw a picture. And 5 pi over 6 puts us in the second quadrant. So our reference angle is pi over 6. It says that this point, we'll call it point P, this point is 12 units from the origin. So our hypotenuse is 12. And what we want to find are the rectangular coordinates, which is like the XY point, which you've been doing since, pre-algebra days. So we want to find this X value on the X-axis and the Y value, which is the height of our triangle. So to do that, we're going to say cosine of pi over 6 is equal to, it would be x over 12. And we get x equals 12 times the cosine of pi over 6 is root 3 over 2. So x is equal to 6 root 3. And because we're in the second quadrant, this is obviously negative 6 root 3. Okay, to find the y point, it's the exact same concept. We just use sine. We're going to say sine of pi over 6 is equal to y over 12. Sine of pi over 6 is 1/2, so this is y equals 12 times 1/2, or y equals 6 and 6. And we found our rectangular coordinates. So rectangular, our point is negative 6 root 3, comma 6. If this were polar, this point would be 12, comma 5 pi over 6. So polar coordinates are basically just another way to describe a point in the rectangular spectrum, right? Polar coordinates are just another way to plot points. So our angle is 5 pi over 6. That's the second entry in our coordinate, and the distance from the origin is 12. That's going to be the first point in our two coordinates. So what are polar coordinates? Well, we have r theta. R is the distance from the pole. And the pole is just another way of saying origin. And theta is the angle between the positive x-axis and the ray on which the point exists. And one thing to take note of, theta is positive counterclockwise. I should say, when it's positive, we move counterclockwise, right? So same as we've always done. And when theta is negative, we move clockwise. All right, so moving on. In class yesterday, I gave you all those funky looking graphs. These are polar graphs that are the circles. What we're going to do is graph these 5 points. So I'm going to do the first one with you, and then I'm going to leave you to do the next 3. So we're going to be together. It tells us that 10 is our distance from the pole, And you'll notice we're going to have to count by twos. So let's say this is 2, 4, 6, 8, 10, 12, and there's a 14 here. C is 0.14. So if we went out a little further, we'll call this 14. Okay, so 10, 3 pi over 2. So we go to 10 and 3 pi over 2. So this is our point B down here. All right, what I want you to do is pause the video and on your own graph points C, D, and E. I'm gonna plot them right now so that when you hit play again, you'll see where they are. So please pause your video now. All right, so one thing that I did to make this easier was I labeled my angles. So this is broken into pi over 12ths. So I have all of the main pi over 6, pi over 4, pi over 3, and pi over 2 multiples. And then when I plotted each of these points, C, D, and E, you'll notice C is down in the 4th quadrant. It's at 7 pi over 4, which is coterminal with negative pi over 4. D is the exact same point as point B. Instead of 3 pi over 2, we're going to negative pi over 2, which is, those two are obviously coterminal. And then for point E, you'll notice I did a little bit of math in the orange that's saying that 17 pi over 6 is coterminal with 5 pi over 6. So E is in the 2nd quadrant at 12 comma 17 pi over 6, or 12 comma 5 pi over 6. So one thing to take from this is that polar coordinates are not unique. And what I mean by that is that if we're talking about rectangular coordinates and you have a point like 2, 4, there's only one way to say that point. It's 2 comma 4. But with polar coordinates, as we see with B and D, B is 10 comma 3 pi over 2, and that is the same as 10 comma negative pi over 2. So each coordinate is not necessarily unique. There's multiple ways to state that coordinate. Looking at F, this is a unique situation. We're at 11 pi over 6, which takes us into the 4th quadrant, but our value, our length of the hypotenuse is negative 12. So we're actually going to extend into the opposite quadrant. So let me get the right color here. We're going to go with red. So F is actually the exact same point as E, because we extend from 11 pi over 6 back into this quadrant because it's negative 12, not positive 12. All right. So one thing to note, another thing to note, I should say, is that when R is negative, we extend the terminal ray through the pole and plot on the other side. And what I mean by the other side is just the opposite quadrant. All right, so let's talk about how we convert between polar and rectangular coordinates. So this is something you're gonna have to memorize. Fortunately, you already have this down, but I'll show you how to do it. So from polar to rectangular. Well, if you think about it, you've got an angle and an R value, right? You've got your R value and an angle, theta. So what we know is that cosine theta, and I'm going to throw x and y in here too, cosine of theta is equal to x over r. So x is simply equal to r cosine theta. Likewise, y is equal to r sine of theta. And that's how you would go from polar to rectangular. Now, let's say you want to go the opposite way. Let's say you want to go rectangular to polar. In this case, I would give you an xy point. So for instance, I give you some point out here, right? This is x comma y. And you want to figure out what theta is, and you want to know what r is. Well, if you have x and y, we can say r squared equals, excuse me, x squared plus y squared. So we just use the Pythagorean theorem to find what r is. And then to find theta, it's just going to be tangent of theta is equal to y over x. And then we take the inverse tangent of y over x, and we have that angle. One thing to keep in mind is that theta is always measured as the angle from 0 degrees to the ray. So the best thing to do, let me erase that. The best thing to do is what I always tell you: draw a picture. All right, it's super important to draw a picture. It'll help you visualize this. So for instance, if your point is in the third quadrant, you're given x and y, you're going to find r. What your theta is this big angle here, right? So you might find what I'm going to call beta in here, right? And then using our knowledge of the unit circle, you can find theta, right? It would just be pi plus beta is going to give you theta. So always draw your picture to help you visualize and complete these problems. The last thing I want us to do together are a few problems. So this asks us to find two different polar coordinates for each point below. The points are currently in rectangular form. So basically what we're doing is we're converting from rectangular, we're converting from rectangular to polar form. As I said in the last section, on the last page, always draw your picture. So we are at 6, negative 6. Negative 6. To find r, simply the square root of 36 plus 36, which gives us the square root of 72, which is equal to 6 root 2. That's our r value. And to find theta, well, first we're going to find this angle in here. I'll call it beta. You can call it whatever you want, alpha, psi. So I'm going to say tangent of beta is equal to negative 6 over 6, right? Opposite over adjacent.